besides unit circle?
Of course.
Next week?
Yes. Circles.
Why are we?
Why is this so mysterious?
Circles are
Yesterday.
360 degrees. Yep.
That's nice.
It is nice. 360 degrees makes sense because
It's 2 pi.
very easily divisible. That's the only reason.
2
really.
pi.
But yeah, there's no real relation between 2 pi and 360.
Well, then why is there a relation? Because someone made it up.
Someone made this one up, and this is actually present in circles. This one, the number 360, is not present anywhere in circles.
Oh,
So it's all made up.
that's deep because the circumference is 2.
Yeah, okay, you're on the right track.
And R
So
is 1.
if we go back to our unit circle, and we set the radius as length 1. We set the radius at 1. What is the circumference of this circle?
1.
So the circumference will be 2 pi times the radius. So the circumference is just 2 pi in this case, because the radius is 1. So that means the distance all the way around is a distance of 2 pi. Yes?
Yeah.
Yes.
Now, if I said, all right, what's the distance half the way around?
1 pi.
It'll be pi. Yeah. And distance 1/4 the way around would be pi over 2. And when we deal in angles, we deal in, when you draw an angle, acute angle, we go, oh, that's an acute angle, that's about 45 degrees, and then as the angle gets bigger, it goes this way, doesn't it?
Yeah.
And it goes this way, and it goes this way, and it gets bigger, and then finally it hits 360. So that's why we can, that the distance here, if we use this kind of distance as the measure of the angle instead of degrees, that is a better way of measuring the angle. So we say that that angle is now in radians. A 90-degree angle is pi over 2. A 90-degree angle, 180-degree angle is pi. A full circle is 360 degrees. But this is the one that occurs if you just have a circle of radius 1. This is what happens if you have a circle of radius 1.
Does that mean the arch and the outside and the angle are equal?
Yeah, well, so the longer the arc, the bigger the angle. Yeah. So, maybe then we can create our own formula for how to convert in.
Yeah, no, I'm writing my notes on.
Alright, how do I convert then if I have 100 degrees and I want to say, oh, I want to put that in radians?
Multiply by 2
Pi
pi.
times pi divided by 180.
Okay, yeah, you can think of pi and 180 or 2 pi and 360. Yeah, because if we have this relationship, 2 pi is 360 degrees, pi is 180 degrees, we can always work in that relationship. If I have 100 degrees, which is a fraction out of 180, isn't it? It's 100 out of 180, and then I can multiply by pi. Or you can set this up, if I have the degrees, I can just multiply by pi over 180, and that will change it to radians. So multiply by pi divided by 180, which is just getting the fraction of the circle it is. Okay, and that is how to convert from degrees to radians. If we have radians, how do we go to degrees then?
You divide by pi and times 360.
Okay, so yeah, if you have radians, you no longer, well, the opposite operation should work, shouldn't it?
Yeah.
So-
Times 180 over pi.
Multiply by 180 over pi will give degrees. As we know, maths usually works in these opposite operation styles. Okay, so that's not too bad. Radians. It does lead us a circle of unit 1 length. Radius does lead us nicely to the unit circle, doesn't it? Or maybe it doesn't. So let's have a little reminder of the unit circle and what it entails.
Did Pythagoras create the unit circle? Did Pythagoras create the unit circle?
I think it was around before. No.
Pythagoras did.
Did he create it? I don't know, actually.
Oh yes, Derek and I were talking about it. Do you think the guy who found pi was named Pi?
Well, pi has been slowly being discovered over centuries and
No, but there's that
like
bad
millennia.
Did you guys read the book?
I think the Chinese came up, found it too. Like first, like they started with the ratio of just 3, They thought it was around 3, and then a little bit more than 3, and then as millenniums passed, like the decimal place got closer and closer to what we now know is impossible to find the last digit, but yeah, they got it more and more accurately to 2 and 3 decimal places. Okay, so this is a circle. I've drawn it on the coordinate plane here. These, this is the x-axis, this is the y-axis. This is the point then 1, 0. This is 0, 1, minus 1, 0, and 0, minus 1. Okay, and 0, 0 in the middle. So this is all about this circle has a radius of exactly 1 unit, doesn't it?
Yeah.
So at any particular point, this length is going to be 1. That's kind of what the whole unit circle is based off, a circle of unit 1. And finally about the relationship between cosine and sine and tan and lengths of sides of the triangle that's created. So if I just have a random angle here and I wanted to find this length, x, let's say, how would I in general find that length of x? I would, yeah, I would go, right, this is a, if I knew the angle, it would be definitely easier. But this is the adjacent side. This is the hypotenuse of the right angle triangle I've created. So that sounds like cosine to me. So cosine of that angle is the adjacent side divided by 1. And of course, anything divided by 1 is just what it was. So that means the cosine of the angle is equal to whatever this length is. Yeah?
Yeah.
And if we did the same process for this side, sine of the angle is going to be whatever length y is, because we divide the opposite side by 1. Which means that this point up here is going to be xy, but we know that x is the same as cosine theta, so it's going to be cosine theta, and y is going to be sine theta. So we can get the cosine and sine of an angle from its x length and y length in this unit circle for all the points when we go around. Yes? Maybe? Okay. Let's take one particular triangle, a perfect isosceles triangle perhaps of length pi over 4. Yeah, well, if it's right angle, it's got to be pi over 4, yeah. Okay, let's say that we're not talking about unit circle now. Let's say we just pick a circle or a triangle with length 1, 1 here. So you're correct in saying that would be pi over 4. And that would be pi over 4 because they have to be 45 degrees, which is half of 90 degrees. What would this other side be?
Square root 2.
Yeah, so 1 squared square root, so that's square root 2. This is just pulling aside from the unit circle our known triangles, so we can start put them in the unit circle. What then would be the cosine of pi over 4 from this?
Plus 45.
1 over 2.
1 over root 2. So we're going to stick in radians for as much as possible now, so just get used to it. And what is the sine of pi over 4 from this? Also 1 over root 2. Yeah. This, if you want to, if you don't like surds in your denominators, you can change that to
Root 2 over 2.
root 2 over 2, yes. Root 2 over 2. Okay, so this is where I'm just going to get my table so I can come back to this unit circle. I'm going to get my table of known angles.
Oh yeah.
Now, if I have an equilateral triangle, not an isosceles triangle. Let's talk about an equilateral triangle. Let's go with each length being 5.
1.
Don't like 5. Is
You
it 1?
do. Why don't you like?
Let's do 2. Let's say each length is 2 in an equilateral triangle. Equilateral we know is 60 degrees, but of course 60 degrees is pi over 3. So each of these angles is pi over 3, yeah? Okay, that's 60 degrees,
How
as
do
we
we
know.
know that it was 5?
Because 180 is divided by 3.
60 degrees is pi
Oh,
over
oh,
3.
oh, oh.
Yeah, it's an equilateral. Okay, but let's say we want to make right angle triangles out of this. So we're going to split this perfectly down the middle. Bisect the angle, bisect the side. So now this side is 1, 1.
Right angle.
That's right angle, that's right angle. This is pi over 6 now, and this one's pi over 6, yes?
Yeah.
I only really care about one side of this because I'm going to because the other side's the exact same. So I'm just going to look at one side of it. This is all stuff we've done before, but no, maybe not.
Yes.
Yeah, you should. So we're just going to look at, I'm missing this side. What's this side? This side. Pythagoras' theorem.
For
2 squared.
2 squared minus 1 squared, who's the short side.
Oh, that could be 3.
That is definitely going to be root 3, yeah. 2 squared minus 1 squared is going to be 3, and then square root for Pythagoras, yeah? Okay, so that means we got a nice relationship here between pi over 3, pi over 6, and some sides. So the ratio of, let's go with, start with pi over 3. Let's go cosine pi over 3. What's cosine pi over 3 from this?
Half.
Adjacent side and
Yeah, 1/2.
1/2. What's sine pi over 3?
Root 3
Root
by
3 by
2.
Root 3 over 2. What's cosine pi over 6?
That's a nice question.
Okay.
Root 3 over 2. Root 3
No,
over
1.
Yeah.
2. Root 3 over 2.
Root 3 over 2, yeah. Adjacent side
Half.
and sine. Something you should start to notice here, if you haven't noticed before, is the kind of opposition of sine and cosine.
For the, yeah.
As in, oh, that's 6, sorry. As in,
They're opposite.
they're, the cosine of 30 is the same as the sine of 60.
Yeah.
Okay, does that work for all angles? As in, like, is the cosine of 20 the sine of... Is is cosine 20 equal to sine 70?
How no?
There's only some way we could find that out.
The circle.
Cosine identity.
It's cosine identity.
Yeah.
I'll just type it into your calculator. Is cosine 20 equals the same as sine 20 or sine 70?
Yeah.
It is
Does?
the same.
Hey, look at that.
Crazy.
Yeah.
So you can always do the swap roof. If you don't like one, you can do the other.
Crazy.
90 degrees.
Yeah.
Wait, 90 degrees?
Yeah,
You
add
went
to
from 20
nine.
to 70.
Yeah.
Yeah.
Or they add.
Oh, yeah, it's 90 degrees, yeah. Yeah. So they're in opposite.
How do they add?
Okay, so we did have a way of remembering angles in a little table. I don't know if you remember this.
I
You need to
remember.
know.
You
Yeah.
have to
remember.
know
Yeah, you have to know the known angles.
like know that like cos 20.
Yeah.
Sine.
Yeah, we talked about, there's some relationships you need to know that, one would be 90 minus the opposite one, but it's kind of logical as well. So this way I would set up my sine, cos, tan
Yes.
table of angles. Now we're going to do radians now. In GCSE, of course, we prefer degrees, but not now. We're more logical creatures. We build up the size of the angle, pi over 6,
How about
pi over 4, pi over 3, pi over 2. You can put in pi if you want.
1/2 or 2 over
Yeah, so I usually just do the first 3,
1.
and I think 1, 2, 3, 3, 2, 1. That's
Yeah.
the way I do it.
Yes.
1, 2, 3, 3, 2, 1, and then I go right.
Over 2.
They're
This
all-
is 1 over 2.
They're all over 2. They're all over 2.
And then
And then
add
you
root
root
for 2.
And then we put roots.
2 divided by 2.
We put roots over, you can put them over them all because root 1 is of course just 1 as well. So we have our square roots there. But do remember that root 2 over 2 is 1 over root 2, some people would prefer that. And then how do I get tan again?
It was you divide them. One sine over cos is 10.
Tan theta, of
It's-
course, is
Sine by cos.
sine theta divided by cosine theta.
It's 1
Sine
over
over
root
cos-
3 and then they
Yeah, so
separate
1
from
over root
each other
3,
and
yes.
negative more.
1 over root 3, this is the same with the same.
It's
and
true,
then-
that's how I thought about it. I was like,
Undefined.
1
Three.
over 1 over root 3 and then I was like,
And
they
then
got a divorce
undefined.
and now it's 1 and root 3 on their own.
Undefined.
Oh, yeah, we're
1,
good.
0.
Did you not think of it like that?
Okay, so then we're talking about 90 degrees.
90, 10, 90 is undefined. Because it's 1 over 0.
Oh, we're not there
Sine
yet.
1.
What's sine pi over 2?
1.
1, 0.
Well, one way to think of it is, this is building up to a larger number, so it's building up to 1, and this is going down to a smaller number, so it's going to 0. You can also think about it if you want to go back to your unit circle, that this is 90 degrees from the start. Remember, we're always taking the positive x-axis as the beginning of our angles, so the angles are getting bigger this way. So here would be 90 degrees, and we know that here, cosine theta and sine theta. What's theta in this case? 90 degrees at this point, so cosine theta is 0 and sine theta is 1. And what is then tan theta? Mira is dying to say
Undefined.
undefined.
Wow.
Because sine over cosine, 1 divided by 0 is of course 0. And if you want to go pi, you can keep this going forever, but we're going to look at this in the unit circle in a second. What is
0, 1,
0, 1, 0? Yeah.
Yeah,
You
it's
sure?
the same.
Absolutely sure? Nothing wrong with that? 0, 1, 0?
0.
Everybody
0, 1.
You're making me
0, 1, 0.
0, 1, 0? Everyone's happy with that?
No.
Yeah.
Aim's happy with that?
What,
Aim,
is
you
it
good?
not 0, 1, 0?
No,
0,
it's
1,
0,
0.
1.
0, 1, 0? Where's 180 on my unit circle again? Over here?
There.
Oh,
Oh,
negative
it's
one.
negative.
Ah.
And y'all.
It's -1.
Minus 1.
Yeah.
So we didn't really.
So now it's 0.
We never drew this line when we did GCSE, even though you should have known it. But now it's,
Oh, yeah.
it's minus 1.
I don't
This is our first negative. This is our first negative.
We just figured that out because it's
The only fun part about trait is the identity.
Yeah, you went.
Yeah.
But one of us is on the line.
You took a look at the point.
Yeah, exactly. So that's what it is. Okay, so we're there. Then we do notice that these are very specific angles. They're really, the first three are only dealing up to 90, or first four are only dealing up to 90 degrees, and then we just have this one. You could put this one on it as well, but then I like to think logically from then on about what your values would be for particular angles. So if you go into the second quadrant, we have a bunch of angles there that we could get the known angle for. But in general, in the second quadrant, we know something about the values of sine and cosine. Like if I have a point here, what's the sine and cosine values? Sine is going to be positive or negative, and cosine is going to be.
It's all actually don't remember.
You don't need to remember it. Just think about it. Think about
All
it.
students take
and
them.
just
All
think about it.
students
An x point here would be positive or negative in this quadrant.
Negative.
All students take
Negative.
Definitely
Only
negative.
cos
Don't-
is positive.
Yeah, just try to logic it out. Don't just remember that. An x value in this quadrant is always going to be negative, and a y value is always going to be positive.
Yeah.
Yes.
So
And then
cosine-
tan is 1 divided by the other, so if the one isn't negative, the division is negative. Yeah? Say that again. Cosine is definitely negative in this quadrant and this quadrant because the x value is just going to be negative.
But it's
So
not-
sine is positive in that quadrant.
Sine is positive in this
And
quadrant.
then tan and then cosine.
Tan is positive in this quadrant because it's minus minus.
Yeah.
And then, yes,
Cosine.
sine. No, sorry. Cosine is positive in this quadrant, yes. Because cosine of a point down here, like a point anywhere in this quadrant, so this might be, oh, it's going to be 1 minus 2. So I know that's outside, but that's, the x value is positive. So that's what we're talking about there. Okay, let's talk about a specific angle now. Let's talk about, what is the cosine of 3 pi over 4?
What is 3 pi over 4 is the first question.
Exactly.
Pi over
360
oh,
divided by 4?
180
Well,
times.
with all of these, with all these known angles, you're going to get over 2, over 4, over 3,
5
sorry.
divided by 4.
and over 6. These are the ones you're
Oh,
going
is
to
it 270?
get, and you're looking here at your known angles.
135.
You know that if you like degrees, that's 30 degrees, that's 45 degrees, that's 60 degrees,
It's
that's 90
cos
degrees,
45.
that's 180 degrees. If you know your angles, this one
It's negative.
is 3 times bigger than this one.
Yeah.
So what quadrant is it in?
Oh, so
In
it's
the
just-
45. In the first one. It's
No,
the
it's
sine
not
one.
minus 1. Yeah.
So it's negative for 2 over 2.
Second quadrant.
Wait,
So
cos 3
remember-
by 4?
3 pi over 4. Remember, 4 pi over 4 is pi.
Oh, what's
So it's less than that. Yes, it's in here.
It's
Oh.
root 2 over 2. Negative root 2 over 2.
Alright, well, yeah, you're on the right track. As in correct. So 3 pi over 4 is somewhere like the angle has gone all the way around to here. I can draw this line in here and I go, this is the angle I want to deal with. But I know from the start, I semi-proved that the x value will always be cosine of that angle, and the y value will always be sine of that angle.
So it's
Yes?
root 2 by root 2.
So I just need to find what's the x value here, what's the x point here. So I actually think about this triangle, not this one, which would be not a right angle triangle. I like right angle triangles. So I'm going to deal with this triangle and think about what this angle would give. It would give root 2 over 2 for sine and root 2 over 2 for cosine. But we know that root 2 over 2 for cosine doesn't work here. It can't be positive root 2 over 2 because it's in this quadrant. So it's got to be the negative root 2 over 2. And that's how I would work out all of these. I get something called the reference angle. This is the reference angle, which is pi over 4. Reference to what? Reference to this table. And then I figure out afterwards, is it the positive version or the negative version of that? Because these triangles are all over the unit circle. As you can see from this, we have a bunch of these triangles that you can draw, and this one actually doesn't have the root 2 over 2s, which is useful, but you can see that they're all just in opposition. These sine and cosine are both negative in this quadrant. Cosine is positive in this quadrant, and so on. So let's look at this is review from GCSE, so let's look at how we get these angles and where they sit and what their values, their cosine and sine values, ratios are. We'll start to look at these in a second. Just in general, if I drew a equilateral triangle and it wasn't side 2, 2, 2, so let's say I had pi over 3 here in the corner, all equilateral triangles with pi over 3. Let's say I had, give me a length of the side.
3 days.
6.
Oh.
6, 6, 6. Would the answer be different for this one, for the ratio?
No.
No.
Sure. Looks like different numbers should be a different answer, no?
No, it's the same.
Division is the numbers.
Yeah, we're dealing with ratios here, so no matter what the triangle size is, the size doesn't matter, the ratio will be the same. So don't be confused on triangle sizes and ratios. Ratios, they're in their most simplified version when we deal with them like this, but they're not the only way it can be represented. It is a ratio. They'll have the same decimal value always. Okay, so how do we do something like this? Let's do one of the more tricky ones here, and I'll get you to do the easier ones, maybe. I'll pick one of the, let's do 2 tan 5 pi over 6, is it? I'm doing k here. 5 pi over 6, all over 1 minus tan squared, 5 pi over 6.
Does tan have like double root? So one word will be just tan double. Is that angle?
Good question. Okay.
Does it have
One thing that you must note is that sine x is, or let's use theta. Sine theta, if I square sine theta, I can write it 2 ways. I can write it this way, or I can write it this way, if I square something.
Oh, okay.
Oh, tan also has a rule.
So, there is a rule for double angles, but we don't need it now, which we'll come to next week. This is the same as this if you look, Alex. So this is probably answering your question. This can be rewritten as this. So you can square the ratio. So all I need to know is what's the ratio. So another way of writing this is 2 tan 5 pi over 6 over 1 minus tan 5 pi over 6 squared. So I can get this first and then square its numeric value. You're thinking of 2 tan, tan 2 theta, not squared theta. Alright, so how do I get tan 5 pi over 6?
But isn't it just formulas?
You can use that if you are insisting on using that formula, you can. I'm not sure it would be very helpful at the moment. I'm more interested in, once I find out what the value of tan 5 pi over 6 is, I'll be able to get a numeric value for this equation. So tan 5 pi over 6. What reference angle am I going to look at out of this list?
30.
Pi over 6. It's in the denominators in the clue. So I go, right, I do a couple of things. The reference angle is pi over 6. The quadrant, I always draw a little sketch just to make sure I'm in the right quadrant. Which quadrant is it in? Which one of these four? Remember, this
The
is
first
first,
one.
second, third, fourth.
It's a negative value.
The first
Oh,
one.
you know it's positive.
Remember, 6 pi over 6 is 180 degrees. 3 pi over 6 would be 90 degrees, that'd be pi over 2.
But what are we talking about? The 10 plus
This,
5?
this one.
Oh, then the second.
Okay.
Second.
Yeah. So the second quadrant is where it lies. So like I did this thing, I'm going to use the reference angle number and I'm going to figure out if it's positive or negative using what
Negative.
quadrants. Yes? So the reference angle number will be the same number,
1 over root 3 as pi over 6.
1 over root 3. So tan 5 pi over 6 is 1 over root 3. It sits in this quadrant though, so its coordinate will be negative 1. Yep. And this then can sub directly into here. And 1 minus 1 over
Root 3 squared.
squared. And now it's, oh, it's root 3. And now I can just work out its numeric value pretty quickly. It mightn't be that nice, but we'll do it anyway. So that's negative 2 over root 3 on top. What's on the bottom?
Because it's in different quadrants.
What?
How do you know which
So it's
quadrant?
1 minus negative.
1/3.
So it's, yeah, you subtract 1/3 from 1.
Wait. Two
Two.
2/3.
2/3. Okay. Can't leave it like this. Can't leave it a fraction.
Is it 2 over root 3? Where's
So
the
it'll be
root of?
3 negative 3 pi root 3.
Okay, so
Oh,
I
because
can.
it's
I can keep change flip to finish it. Okay, you get it. Multiplied by not root 3, just 3 over 2. Keep change flip. Okay, the 2's cancel. And I have negative 3 over root 3, which you can get the Cert out of the denominator if you like.
Bruh.
What would it be
Root 3 over 3.
if I did,
Oh, no. 3 root 3 over root 3.
which is,
3 root 3 over 3.
Which is root 3.
Which is.
well, we'll write
root
it.
three.
Negative 3 root 3 over 3. If I did that out, and the 3's would cancel, which is
Negative root 3.
Oh, we got it. That's the answer to that one. Alright, you do the rest. Or a selection
Oh.
of the rest. So what's my step? I go, right, what's the angle I'm looking at? What's the reference angle if required? Some of them are already reference angles. Right, and that's the numeric value I'm going to use, and then I'm going to figure out if it's positive or negative using my little sketch we circle. Okay, so some of these are going to be easier than others. Squared, remember, I square after. I use the inner bit and square the result.
Is